All right. And so, what this class is all about, we call it program management for electricians. And basically, what we do is we go over a couple of things. We review the electrical set with you, so you'll have a good idea of when we produce an estimate, what we look at, and we'll go over that very quickly. Now, if you want to have some basic plan reading classes in more detail, just let me know. So we'll go over the electrical set. We'll go over pricing, and then we'll also go over a actual professional estimate, electrical estimate, how it's formatted, and what you should be looking for when you get that estimate from another maybe sub that works for you, or when you present one to a GC, so they are assured that everything on the estimate is based on the scope of work, and it's very clear. And the GCs look at a lot of estimates, as you know, and so you want to make sure yours looks professional. It has everything that they may, if they have any kind of knowledge of electrical, which a lot of them don't, but some do. If they have any knowledge of the electrical scope, they'll know what to look for when they're looking at your estimate. And so that's what this class is all about. First of all, to review a set of plans, and then to review the estimate and go over each part of the estimate, and also to help you understand that there is, when it comes to pricing, there's a standardized way as far as how long something's going to take you to do any scope of work in construction. There's a standardized way based on construction standards, how long it should take you to run a linear foot of conduit, how long it should take you to install a switch, how long it takes for a 42 position panel to be installed, how long it takes you to install a breaker. All of that stuff is standardized, and if you could make sure when you do your estimate that you base your labor on those that standard, then you'll always, at least my clients have always been guaranteed to be like within one or two or three of the winning estimates. And that's really what you want, right? When you spend so much time on an electrical estimate, you want to make sure that it's at least in the running, because it takes you a long time if you do it right. So that's what this class is all about. So we're going to start by looking at the set, and this is just a set of, I'm not even sure what this is. This is a Chase Bank. Well, we're going to look at the different sheets and kind of make sure you have, or you're familiar with the different sheets. So tell me, I'm assuming you work for the electrical company, because I saw your email. What exactly do you do? And tell me why you're taking the class and what you hope to get out of it.
Okay. I work in an electric company right now. I am basically the president of project. It was, and he's awesome. He's been in our town since '84. And it's the biggest, well-known electrical company here. So he's so knowledgeable and very informative, and so myself just like to ask and fully understand questions, and I just wanted to get a better understanding how I can use um, different programs, and sort of like a, I guess a step by step of what section I should move on from. Like after I'm doing like the fixtures now, okay, then when I should go from
Mm-hmm.
on. So that's kind of what I'm hopefully
Oh, okay, okay.
here.
So you do, you assist in the estimates yourself.
Yes, ma'am. I'm
Okay,
using a
good.
program right now to do my takeoffs and quantity count.
Uh huh.
But
So just know you're kind of cutting in and out. So I don't know if that. Am I cutting in and out for on your end?
no, you
Oh,
are not. Is
okay.
that better?
Yeah. Well, we'll see. Let me see, because I want to make sure when you get the recording, you hear yourself completely. So I'll let you know if it's cutting in and out. Okay. So you do estimates now. Do you just do the counts, or do you also help them? You have a linear tool where you do the linear measurements as well.
Yeah, I've got the wheel tool, and also
Uh-huh.
Kind of different also, but I always have to double check with the real set of plans and paper.
Okay. Okay.
And then I send out quote requests to vendors and put the pricing together on estimates too.
Okay, good. So this class is perfect for you. Okay, so a couple of things.
Yeah.
Yes, a couple of things to save you time. Now, I would recommend if you guys are the biggest, if you've got a lot of resources behind you, I would recommend and write this down that you, and this is what I've used since, and this is my 13th, 14th year now in doing it, and it makes doing the linear measurements a breeze. Okay, so the name of the software is Plan Swift, and that's what you're looking at right now on the screen. It's called Plan Swift Professional, PLANSWIFT, Plan Swift. And I'm not affiliated with him at all, but I know it's made my life so easy because we do all estimates and all trades, but it's just so easy to use. And as far as the counts and forget the wheels and forget ordering the sets of plans until you actually start the work, which you need them right when you do the work. But to do the estimate, all you'll need is the PDF, like you see here. You upload it. I'll show you by what I'm doing, how I'm teaching you right here, and then again you'll have the video to review. But yeah, you can knock out an estimate in a day, so that means you can knock out 5 in a week if you have. And then again, if you need assistance in estimating, we teach that as well, and I'll be more than happy to show you. But a lot of the videos now on that study page, it's all about estimating. All 5 of the videos for the electrical is estimating pretty much. What to look for in the lighting plan, what to look for, or how to review the power plan, the single line diagram, how to match them up. So make sure before tomorrow at 5 o'clock that you review that stuff again. And if you find that you want to take an estimating class, just let me know, and then I'll give you a good price on the estimating class. Because yeah, between using a good software like this and you already having a basic knowledge, you'll be able to make the company a lot of money because you'll be able to knock this stuff out for them, or at least be able to review the ones that you get from other people or whatever. And yeah, so let's get down to it right here. All right. So now what we're looking at, of course, is the cover sheet. And so when you're doing your electrical, it really depends on the architect and the engineers on the symbols. You'll get a symbol in one set that you'll know what it means. Okay, that's a duplex outlet. That's a switch. That's a single pole switch or whatever. But then you'll get another set of plans, and because of the style of the electrician, the style of the electrical engineer, the style of the architect, it'll be the same symbol, but it'll be something different. Okay, so just make sure you always review all of your symbols ahead of time. When it comes to the lighting plan, you have a lighting schedule, and the lights are all A, B, C, or P1, P2. I mean, that's easy. And when I do the estimates, I pretty much do the electrical set first. The power plan, electrical set, or the power plan first, because that's the most difficult. The lighting plan is easy because all you're doing is naming a light, click, 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 click. But when it comes to the power plan, you gotta you will have to read the keynotes, right, which slows you down. You will have to. There'll be a lot of different special outlets, right? The special receptacles as opposed to just the duplex, as opposed to just the GFCIs. Some may be in the ceiling, some may be in a counter, right? So you want to be able to detail all of that. So that's why you pretty much, I do, just to save myself time, because you'll be doing a lot of them once you get good. Trust me, they'll have you doing a lot. To do the electrical set, the power plan in the electrical set first, because that takes you the most time. And we'll go through all of it. All right, so all of the symbols, so just make sure you always, especially when it comes to the telecommunication devices, right, and the fire devices. They're gonna have this T1, T2, T3. What is that? But when it comes to your electrical set, when it comes to the communication devices, right, when it comes to the fire, when it comes to telephone, when it comes to computers, the only thing that the electrician provides is the conduit and the junction box. They don't provide. So we have low voltage electrician and a high voltage electrician. These sets of plans, what we're going through is for the high voltage electrician, which is the electrician that provides the power to the building, power to the lights, power, all of that. Then the low voltage electrician does the power for the HVAC wiring and the telephone and the computers. Okay, so that's the difference where the electrician, high voltage electrician, they'll provide all the conduit and junction boxes those other low voltage electricians need. And so when we do the estimate, we always have to say, yeah, all the J boxes and all the conduit for telephone, for the alarm, if there's speakers, if there's, all of that is low voltage. Speakers, telephone, computer, alarm system, security system, yeah, all of that. Okay, and two, if it's like a, what have I done? A couple of like Chick-fil-A I've done, right? Where they have the loop for the, now we're talking about site work, right? So the loop, like the loop detectors when they drive through, well, you have to have the conduit. An underground conduit is always PVC, right? So we always say when we see site work, even if it's the lighting site or whatever, it's always PVC or underground. And so again, if it's stuff like that, like drive through all of the wiring for even a gas station, which is a nightmare to do a gas station like a 7-Eleven that has also gas. Well, yeah, you got to do all of the PVC for all of the controls for the pumps, all of the controls for what all the light, all of that. So when it comes to electrical set, if it's from the ground up, give yourself 2, 3, 4 days because you want to be able to look at it first, go through the hardest parts first, and then be able to put it all together. Okay, so electrical is a different beast because when we talk about the wiring, we have wire assemblies, right? So we have a wire assembly for the feeder, could be what? Number 300 plus a number 8, all in a 2.5-inch conduit. Well, if you're doing the takeoff for that, you have to do the actual takeoff from the scaled plans. And so it's a lot. But then again, that's why electricians make a lot of money because this is a lot. All right, so let's go to now. This is I think it's also demo, but we're not gonna go over the demo part. Yeah, this is a demo. All right, so here is the power plan of this bank, and so you always want to make sure you know what your symbols are looking like. But then I know that okay, this is regular duplex outlet, so I would just start counting. But when you review it, I always start at one end of the building and just work my way all the way around, so you don't miss anything. And so what I always do too is now you have to do the counts, which are G. I already know that that's probably a GFCI, right? Because you're always going to have ground fault interrupter circuits, duplex outlets where there's water. So I'm from doing this forever. I know I don't have to look at the symbols list to know that that's a GFCI outlet. That's why they have the G there. Okay, as opposed to not having anything there, like right here. Well, I know that's just a regular duplex outlet. Okay, so the thing about the electrical, right? Exactly. So, but then again, the symbol is supposed to tell you. You're supposed to be able to look at this, look at the symbols list, and get an explanation of what it is. And so when I do the takeoffs, I always do the counts first. Okay, so I'm going to go through and do my counts because I have to do the counts, but then I also have to do the wire runs. Okay, and so that's why I start with the electrical set because it is such a more I want to say a pain, but it's more complicated. Okay, so I'm going to quickly go through this because we do only have 2 hours. So the power plan, right, is or these outlets are all the power that comes through the building. And so what this is telling the electrician is basically these numbers are telling the electrician what? Do you know?
Isn't that what panel schedule they go in?
Right,
Or
right. That basically it tells you what position on the panel. that
Yeah.
these are going to. Right. So when you see that all of these are going to the same position on the panel, 3333, that means they're all daisy chained together. But they're not going to show you the wire, right? Because if they showed you the wire, you wouldn't be able to see anything but the wire on the plan. That's why they don't show you the wire. But they give you the position. Hold on one second. All right. So they give you the position by the outlet so you know when you have to do the wire runs. Okay, so let me just show you what I mean. First of all, you got to scale it. So we got to find the scale. And it's always somewhere. There we go. So what's that mean? For every quarter inch I measure is really 1 foot. And so I tell Plan Swift my scale right here, 1/4 equals 1. And so I agree. So again, I'm going through and I'm doing all the counts. Are they regular duplex outlets? See, now this is telling me what? What's this telling me? PP2 number 10. What's that one telling me?
That is to the panel. Oh shit.
No, go ahead. It's telling you two things actually.
Okay.
One thing is telling you, well, PP2 must be a panel because this is power, so you know it's going to direct you to,
Okay.
right? So that's right. But number 10, it's telling you what's that arrow called?
Oh, that's the number of runs.
That's a home run.
Yeah.
That home run means I'm going to go right from that outlet. What do we do when we hit a home run? We go from that position all the way to wherever it's telling me to go. So what this is telling the electrician is a number 10 wire is going to go to PP2. Now, where in PP2? That's where we might have a mistake, see? And we do sometimes have mistakes. Because this is telling me, now let's look and make sure PP2 is the panel. Hold on, because we're going to go a little farther down and find all the panels. Here are the panels. All right, yep, PP2 is a panel. But see, where that was missing is where on PP2 am I going to run that number 10 wire? So if that is the case, then maybe on the panel it gives me the wire configuration for something, but it doesn't. See, so that would be something I would tell my electrician. It's like, okay, let's go back. That was a good mistake to find early. If I can find where we were over here. Oh, Lord, I don't know where we were. Yeah,
We were right.
so this is the same thing. I don't know if this means PP2, because that can't mean number 1 wire. That can't mean that. That can't mean that. Because you wouldn't run a number 1 wire. That's a feeder wire. Number 1 wire is a feeder wire. You wouldn't run a number 1 from a GFCI outlet. So that's telling me we found a mistake, which is good. This is probably saying, yeah, right, that's saying that position number 1 in PP2 is where this is home run to. Because when you do wire, right, you have to actually do the physical links of this. You have to, and when I say that, now let's go back to, now that I have scale, now we have these notations above the outlet. So if they are all 3s, that means they're all daisy chained together, and I do something like this. I call it power wire. Because usually when it's daisy chained together, the electricians are allowed to use MC cable.
Mm-hmm.
So physically, right, they have to physically connect this. So that's telling me that physically all of these number 3 wires are connected. So if I'm doing the power wire, there's 2 different types of power wire you do in the power plant. The MC cable, which you're allowed to use in these situations, but not in the home runs. Home runs are either 9 times out of 10 is a number 12 wire unless it tells you.
Right, 12 2.
Yeah, 3. Well, for lighting, it's usually 2 number 12s. But for power, right, it's 3. You have ground, hot, and neutral. Cold, hot, and neutral, right? So the wire configuration is always going to be 3 wire unless it tells you otherwise.
Yeah.
So when I do the home run, if I know the home run is 100 feet, right? If I know this home run to PP1 is 100 feet, actually it's not because PP1's right here. So whatever that distance is, I know it's, if I know that's 50 feet, then I know I have what? 50 times 3 of number 12 wire.
Yep.
Because home runs are always 3. Unless it tells you different. Now, when you have mechanical equipment, that's when it's not always a number 12. Okay? It's not always a number 12 when you have big equipment, a mechanical equipment, that, even the panels aren't number 12, right? It's usually just the regular power components where we have a number 12 wire. Okay, so let me stop right there. Because the only thing that we have coming in as far as power into every building, no matter where it is in America, we have 12208 alternating current, right? So we have 12208, that's what we have coming in every home. 12208, 60 hertz, 12208, 12208, that's the alternating current. Well, you can imagine everything will need a different power requirement. Think of it this way. You can't use your phone charger to work your microwave, right? Right, because those charging cords and the microwave cord is the wire configuration that is needed to convert that 12208, 12208 to the requirement to run a microwave, right? That boost it up to run the microwave or boost it down, right, to power your phone. Imagine if you tried to power your phone with a microwave cable. It would blow it up, right? Because everything that in a building has a different power requirement. And so how we change the amount of power that comes to a piece of equipment is only through that adapter or the cable that we connect to the outlet. Okay? And so sometimes things are hardwired, which means like sometimes like in an apartment complex, they'll hardwire the refrigerator, which means it's not connected to a plug, but it's connected through whatever wire configuration directly to the panel. That's hardwired. Okay?
Yep.
So, when you're doing the takeoff for the power plant, you want to make sure, okay, you're doing all of your things that look alike. So these are all GFCIs. These are regular. That white is data, right? Or computer, where telephone, voice would be black. And again, remember, it's not a standard thing. It really depends on the style of, I've had, it really depends. But generally, white means data, black means voice. So this would tell me that this is a communication, maybe a computer outlet. So for the electrician, right, the high voltage electrician, they would provide only what? The junction box and conduit to the ceiling. So when I do this takeoff for any of these, I just say J-Box communication or J-Box voice or J-Box whatever. I know automatically that I have to have either a size, 3/4 inch or an inch conduit. And it's always just to the ceiling, okay? It's never, unless it says run it to the communications room or something. Okay, so as far as the takeoff for that, just know, anytime you see these, you want to look again in the symbols list, because in the symbols list, they may tell you this is a duplex, right, which is 2. So it could be 1 outlet, or it could be 2, it could be 4. Sometimes they'll put a 2, 4, 6 to tell you it's a computer outlet with 2 outlets in it. Okay, so be mindful of that too. And it really go ahead.
Okay. So is it always smart to have a print off list of your symbols?
Oh yeah. Oh, every time. Every time. And what I do, and the good thing about this one is that I can, let's go back to, where is that? The symbols list. See, I can go to a symbols list right here, and then I can tell it to print screen. That way, I don't have to print the whole thing, until you get, or you could just look and see, okay, if I see that G, then it's a GFCI, That's the
And
good
that
thing. Go ahead.
that plan switch, you know how much is that like a one time purchase
Yeah,
type thing, or
right.
is that just
It's a one-time purchase. Now, look, the funny part, they know how good it is. When I bought it 12 years ago, 13 years ago, it was $800. Now it's about it's double that. It's 16. But you know what? You make that back in one project, right? I mean,
yeah?
really. If an electrician, you make that back one, two projects, and you'll have it for life. I still have the same one that I bought originally. The one we're watching is like I have like Plan Swift 9 point whatever. Now they have Plan Swift 10.15. Okay, and you know the revisions are like point 1.1, right? So they've had a
Mm-hmm.
lot of revisions, and I still have my original that I paid $800
It
for,
works. It still works
and it
good.
still
That's
works.
awesome.
It still works. And the thing about it, like I tell everybody, it's a ruler, right? It's a ruler. I mean,
It's a tool. Let's do
right?
it all for you.
It's like a hammer. How many times you got to replace a hammer? Never, if you treat it right, right? And
Yeah.
two, if you lose it in your computer, like your computer dies, gets a virus, there's somewhere for you to go and download another. You know, in depth, you can download it forever. You know what I mean? Because how many computers I've lost over 12 years? I just go back and download another set. You know, the original, you can download it again, so you'll never lose it. You know,
Okay,
and
that'll make
yeah,
that's
and
cool.
two, if you use it at work, you it's a license that you can only use on one computer at a time. But you can download it off your computer, and then like once you go home or the next employee working graveyard or whatever, they can use it too. So two people cannot use it at the same time, but you can download it off a computer and upload it to another one in a different location.
Right. Alternate times. Okay.
Yep, yep. So but yeah, I mean, it's worth its weight in gold for sure. Okay, so let's go back to. Okay, that's a demo. Okay, so we just want to make sure we know that that is underground conduit, and so we know that that's going to be PVC, right? And we're always going to look at the keynotes. And one thing is that I kind of look over before you get a set of construction documents, and you know you're going to bid on the set. Make sure you always review the specifications because
Right.
the specifications are the written words that go with this project that tell you the type of material, how they want you to install stuff, if they want submittals or whatever. But two, if there's things like temporary lighting that's required or things like that that aren't necessarily shown on a set of construction documents, it'll definitely be mentioned in the specifications, right? Or if you need a generator or something and you happen to miss it in the
Right.
documents, it'll
The
definitely be in
power.
the specs. And then that way you won't miss it. So I always recommend review the specifications in detail, take notes, then review the construction documents, take all of your counts, take your measurements, and you'll be ready to roll. So when I do a set, I do the power plan first, review all of the keynotes, make sure I understand what they're telling me. Is it's above county? 9 means something, so we look at 9
Mm-hmm.
and recommended location. Are these the keynotes? Yeah. Recommended location of cellular antenna, da da da, roof penetration. So that's those kind of things that as an actual electrician, okay, you want to account for the roof penetration by how many of them do you have? Because I know, and I'm not an electrician, there's a special kind of connector to go through, to go through the roof. So you need something special for
Yeah.
that. So you want to make sure that things like that you even account for, even though there's not nothing, there's not something actually there to
Right.
1, 2, 3. In the process of doing what you have to do, that there is a special connection, through wall connection.
Right.
You
So
know,
that one could be $600 instead of $40.
right?
What you
Exactly. So that's why you want to make sure, especially on the electrical set, you review
do.
all of the keynotes. So two keynote number one is two number one conduits running slab, two floor box for power data, and then you got to run it up too. Now when I do my
Mm-hmm.
runs, I just do horizontal runs, I'll just run it here. But then when I finish, I'll add 10%
Okay,
because
10% away.
of
That's
what I.
that's my thing, right? About when I do a measurement, I'm so nervous on like what way to run it.
Right,
I'm like, okay, I clearly can't go. I don't know, but I clearly can't go from 80
right,
over to number 33. I have to go up and around and
right.
the
Okay, so
way of
yes. Now, look, that'll drive you crazy. Okay?
right.
So, the one thing I do when I do the wire runs, I just do it in the most neatest way possible. Because you're not
Right.
trying to be exact, right? You're trying to give it an amount that is comparable to what would be there. You know what I mean? So, when I do the wire runs, so like this one I did, right? I'm going to do it in the neatest way possible because I know you
Yeah.
as the electrician,
It is.
you're not going to run it all crazy, right? You're going to go from point to point. Just like if you all of these are 35s, right? So you're going to run the wire. Now, are you going to run it like this as an electrician? I don't know, you might. But I do it as neat as possible. And it's so funny cuz my son now he's an electrician and I taught him how to do
Yeah.
I taught him how to do estimates for me like years. And I see his work now and it's like immaculate. It's neat. It's like from point to point. Okay, so if
Yeah.
if I'm going to do so you don't have to worry about, oh, should I go from here to there, because what you want to do is just remember all these are 35, so I know I can use MC cable.
Yep.
And so I'm just going to do that because even if my electrician is sloppy, well, I've covered all of that. And I mean, I'm going to do it in the neatest way possible. That way I'm not going to be short. See, and again, you're not on the wire and conduit runs, you're not trying to be exact. You're trying to get an amount that's comparable that will cover the job. And if you go from point to point, add 10%. Okay, we know these are all sevens. And so all of that. And now I'm better reading, and I'm even going to go through the door, right, to connect to seven or wherever the next seven is. And so I know that all of these are sevens because now I know, now that I'm better reading the set of plans, I know that this is telling me the home run to position number seven. Well, if that's seven, that's seven. Yeah, position number seven on the panel. So I know all of these with this seven, I can daisy chain together.
Cool.
But you see, this says
And then
number nine.
you said here, I have a question.
Uh huh.
With at home run, the little number over the symbol is the slot section, right, for the panel, but then
Yep.
the arrow over the line is the amount of home runs. And you said you times that.
Okay, so once I do all of these, right, that I know are daisy chained together, I'm not finished. But assuming we're finished, right, this number seven needs to come down too. Just keep that in mind. So assuming that I'm finished, okay, so now I'm naming something home runs. And then I'll name them power home runs because I separated for the lighting home runs too when I do the lighting
Oh,
plan. So just so the electrician knows, because they don't know what I'm doing, right? And so I send them a copy of the takeoff recorded, right? I also give them, and you'll see when we go over the estimate, all the relevant measurements. So I say, yeah, this is a home run for panel PP2. Here's the total home run for panel whatever. Here's the lighting home run. So they can, because they do it for a living, right? They can visualize that and see if that makes sense based on the plans, right? Because they've done it a
right.
lot. They just need somebody that's going to accurately do their best to measure it as accurate as possible. Okay, so imagine I did
They need us.
all. Say it again.
They need us to do it. They aren't patient enough.
Right, and two, I'm really. I mean, seriously, they're really not. Considering they got to go do it too, it's like that's why I loved specializing in electrical because I know I can be very detailed and save them a lot of time, and to help win. I have a really good track record with my electricians. They get up there really close and they win. So it's like, yeah, this is
Yeah.
how we get very detailed when it comes to the takeoff. We use good software. Then when it comes to the pricing, and that's what we'll go over after. So let me go back to assume I did all of the wire runs that we can daisy chain. Everything that's got the same position, we know we can daisy chain. Now, once it comes time to the home runs, I just go to all of where I know there's a home run, and I just go from that position to now this is PP2 and right here. This one's PP2. I go from that position to PP2, same position. This one, this is going to, now this is a junction box for the power alarm. So I'm going to say I've already counted that. J box fire. So I'll know it's a junction box for the fire alarm, but I'm still going to, because it's still a home run to PP2. Okay, so you do that all the way through. Everything's a home run to PP2 wherever you see it. And so by the time you finish, right, you'll have a total. Right?
Okay,
so
and it's just the receptacle or the symbol with the home run symbol.
right, because that right,
The PPT.
right, because that's the whole purpose of a home run as opposed to nothing on it, right?
Everything else is connecting to that in the daisy chain.
Right, exactly. So it's telling the electrician this GFCI is connected to this one. But you see, okay, let me show you the difference between, you see this has a 7 GFCI and this doesn't, but it has a home run. So what this is telling me, this one outlet in itself is a direct home run to the outlet. Because I'm sorry, to the panel, from the outlet to the panel, because some equipment has to go directly to the panel for power. So some are daisy chained together, just like all of these, right? All of these, 17, 15, 37, 8, all of these are direct home runs to PP2 position 17, PP2 position 15, PP2 position 37, position 8.
And would that be different from labeling it quote hardwired, or is that fixing wired?
That's basically that's hardwired. Well, no. It would be hardwired if we would have something like the box, the junction box, like this one. That's a junction box for something.
Right. And then it's direct.
And then it's directly, yeah, very good. That's a good question because the outlet lets you know that it's plugged into something, right? Because that's a duplex outlet. That's a good question. All right, so know that the symbols, right? This connected to a wall, so I know that's a junction box connected to a wall. But this one, right? If it's in the middle of the room, right? We know that that is a junction box for a camera, CAM, or the power for the camera. I see. I gotta look at the symbols, right? But I'm assuming that's a camera. I'm assuming a lot because I've done a zillion of them, so I'm assuming that's a camera. But
Okay.
yes, but you know when you assume, you know what happens sometimes. So, but yeah, in the final analysis, yeah, I'm gonna go through because I'll say ceiling, J box, CAM. So when I go through and I'm finished with my takeoff completely, I'll print it and then I go through each step and fill in the estimate like I'm going to show you shortly. All right, so the power plan, that's why we're spending so much time on it because there's so much little stuff. If you see a symbol in the center of the room, right, you know it's in the ceiling. And so a junction box for the labor, right, is going to be more to put it in the ceiling than it would be to have it on the wall. So just, just be mindful of things that are in the ceiling like that one. And like this, right?
Elevation schedule and make sure he doesn't need like a lift or something.
Right. Well, you know what? That's a good thing too. You said that because all of my estimates have a standard place for lift because they got to have a lift. I mean, they're going to go higher than 6 feet anyway, right? So if they go higher than 6 feet, they got to have some way to get up there. So that's kind of like a standard item on our estimates that you'll see. The lift is standard. Overhead profit is standard. We have a spot for the switch gear separate from the lighting package. Okay, and that's another thing. that when you do the estimate, right, the first thing you need to do before you even try to put it all together is do all the counts for the lighting, and then you send that to your supplier, right, to your multiple suppliers, because it's going to take them a while to get back with you with the number. Because I've helped an electrician, and it's like we send it to 4 people, and it's like we never get them back on time, or we'll get one here or one there. So the first step in making sure you have everything you need is to get these counts done for the lighting, especially all the lighting and the lighting controls, and then send them the e plans. Right. All the You don't have to send them for the outlets and stuff like that, because they'll give you a package for the switch gear and the breakers and the disconnect switch. That'll be one thing, and then you'll get one other price just for the lighting and the controls. Okay, so we need to get out of the power plant. But do you have any questions about the power plant?
The only other part that I noticed that I struggle with is after I get my counts and everything, and like for say the power plant, it's going through, and what I've done is I use the panel schedule
Uh huh.
to see what type of wires
Exactly.
each of my little symbols need.
Yeah.
Is that correct to do that? Is
See,
that what you would use this power plant to do, or
there's a multiple ways. So you know that, or just know that the regular outlets are all number 12s. Okay,
yeah,
and the daisy chain, and you have to ask in your state. All these daisy chains. It's usually MC cable, and it could be MC cable with 3 wires, 2 wires, 4 wires. It really depends on. And we usually just use 3 wire MC cable with 3 wires. The same as the home.
yeah,
Remember, everything is 3 wires because we have a hot, a cold, and a ground, and a neutral. Okay, so everything, each of the components have to be connected to each of those three, and then some components have to be connected to more than that. Okay, so just know that everything's going to be that 3 wire. Now, as far as so, and again, most everything's going to be number 12. Now, some plans, if it's not number 12, say for instance your mechanical equipment, if it's not number 12, it may say in a couple of places. It may say on the keynotes, right? It may say directly in like I thought that one was a number 10 wire, right? When it was just telling me the panel. It may tell
right,
you at the home run. But yes, you're absolutely right. Now, it may also tell you, and it should tell you if and it may not all the time, but it should tell you in the panel schedule. Okay, but sometimes it doesn't, because this is a lot of mechanical equipment. Another key, another key to where the wire may or may not be number 12 is that if you have more than two, if it's more than 21, right? 20 amps, 1 pole, that's usually number 12 wire. If you have anything more than 2 poles, 3 poles, it's probably a number 10 wire, 2 number 10s, 1 number 8. And see, this set is sucky because it doesn't tell you. Okay,
right.
it does not tell you. And so what we'd have to do is give an allowance. Okay, because all of these panels, now again, anywhere you see 21, it's probably guaranteed that it's a number 12 wire. Okay, so
Yeah.
like everything connected to PP2 is probably number 12 wire. Even the exhaust, even the exhaust fans. Because again, if you see 21, 20 amp, 1 pole, that's usually telling me the wire connected to all of the branch circuits and all of the home runs are number 12. The only thing to question is when you see 2 pole, 3 pole. And then sometimes it doesn't mean that it's not a number 12. But if it doesn't tell you, you just need to make it known that it doesn't tell you. And then, a lot of times your electrician actually does the work. Will know, okay, make that, 2 number 10s and 1 number 8. Or the other way around, 2 number 8s and 1 number 10. You know?
Mm-hmm.
But
Right.
the the
This
key
this
to it,
was that.
Yes. The key to it is, yeah, you look on the panel schedule, and most will give it to you. If it doesn't, uh, you know, you have to ask.
Right.
Because it really should. Now, there'd be no reason why they didn't give it to us here. And again, just keep in mind, anytime you have more than one pole, it's probably a different wire configuration. And your electrician can probably figure out what it should be by these numbers because that's what they do for a living.
Yeah.
You know what I mean? But for a estimator, yeah, it's supposed to be there. You're supposed to tell me. And in this case, I would tell my electrician, hey, I don't know the configuration for the mechanical equipment. It's not telling me, so I'm going to use this or this because I've done a million of them. You know what I mean? And don't.
Yeah.
Mm-hmm.
That's my hardest part too. Is with my boss, I guess, is wanting me to study electrician and figure this out. I've been coordinating with the coach that we had.
Uh huh.
It's been a little easier,
Yeah.
but
Well, yeah. That's
I'm
another
glad.
thing. If they're gonna teach you how to do it, that's great. Yeah.
Yeah, and it's use the panel schedule to figure out all the wires and what the
Yeah.
Do you think that's
Oh yeah.
that?
Definitely.
Okay.
And again, if it's not stated, and I would look at the electrical keynotes very carefully
Mm-hmm.
and the keynotes for the rooftop equipment because it may tell you somewhere in there. It may or may
Mm-hmm.
not. You never know. But if it does, I would look
Yeah.
very in detail for that. But existing, da, 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 yeah,
And
extend.
I just too, because I was studying the with
You cutting out again. You cut out
oh
again.
sorry question on the when you're doing the plan takeoff right
Uh huh.
the different I was told and I've read up on that you should do your fixtures lighting and clean and your wires and change and your this and that
Oh.
do you really have to have a matrix or is it you have a symbol or
you
that
know
you know
my the Plan Swift. Let me show you. Right, because Plan Swift
okay
gave it a color. It just gives it a color. So you
right
can you can give it a color. You don't have to. Our thing is estimators. We just need to do the measurements. We don't care what the color is. You know what I mean? So
yeah
yeah.
okay I found my note I read from a note that it said create a color scheme for system or scheme for lighting fixtures for blue and
Oh
that's what I thought was ridiculous too because on those
yeah. No.
plans but the one that I use it
Uh,
doesn't automatically give a color it's like you pick it
oh well yeah. I mean, but really, color to me is like if you name stuff, like if you have to name it what it needs to be named, and then go on. You know?
doodle don't go by the color
Yeah, yeah. Go by the name because we're naming stuff for a reason, so we can go through it once we're finished. Okay. So, any more questions on the electrical set?
no man
All right,
I
and
got it
this part sucks. You see this cutout, call out,
yeah
basically electrical call out. Okay, so it's called out. So we go to image number 2 on E2.1, which is on the same page, which is right here. So, but keep in mind, you still have to do the home runs, right? But they've taken it out of the position where you could easily do the home runs. You see?
yeah
You
and
s-
they changed the measurement
and the scale is different. And so for
yep
something like this, actually, for something like this, is it 29? So you'd have to change your scale real quick because only this one's 29 and this one looks like. Now let's see what number 2 is. Keynote number 2. Outlet for building automated systems and coordinate. Okay. Because it looks like it's in the ceiling,
mm-hmm.
this one. And
Yeah
so
it does
27, 29. So yeah, you would have to, because yeah, these 29s are daisy chain. And then home
yep
run.
totally
Okay. And then, yeah, but it looks like everything else is a home run. And so what you could do is guesstimate. right? So you go back here, and just run the home runs. You know, go back to the regular scale, the scale of this, and just run the home runs. You know, you're not going to be, and again, when you add your 10%, you're going to be good. And keep in mind, when it comes to the wire and the conduit, you're not trying to get it exact. You're trying to get your measurements in there enough to where it's comparable. Add 10%, and trust me, you'll be right on the mark. And don't forget to multiply by 3, right? The conduit is 1, so if I've got 1,000 feet, I've got 1,000 feet of 3/4 inch conduit. But what? I've got 3,000 feet of number 12. Okay, so now let's go to the lighting plan. All right, so that's the roof plan. So when we do the roof plan, what I do too, if I have to run the wire, see, we got a new outlet here. So, and it's waterproof. So you got to kind of guesstimate where the panels are, right? Because I think these are probably going together. Let's see, position 41. Yep. So what we got, all of these are going together. So when it comes to rooftop unit, what conduit are you going to use? Rigid steel? Is it going to be PVC? I don't know. We just want to get a good measurement, and your electrician can tell you the type of conduit we're going to use, but it's still going to be number 12 wires unless it says something different. And then we've got to get these all together, and then, we're going to assume, where was that panel? Somewhere at the end of the building over here. So we've got to just run it. And then when it's on the roof, I add 10 feet, right? Because we got to go down. So I automatically add 10 feet on anything that's on the roof. So if I had to connect all of these, I do the same thing. But I think these are already existing, or else they would tell us something. We had to do something with them, right? If they're already existing, then it's not telling us to do nothing. Or, we got to read the keynotes. It may tell us. But then the same thing here. If I have to run power, I'll just do it from right here to where I think the panel is and add 10 feet. Because, again, you're not trying to be exact, right? You're trying to get something that's an allowance, that's comparable to where you're not under. Okay? Okay, so that's the roof plan. Yes.
For what you said conduit by 3. So,
right.
You have 1,000 feet of conduit. You have 3,000 feet of wire.
Right. So, for instance, if let's just say it's the home runs, right? If you measure like we did, 1,000 feet of home run, which means, right, you've got 1,000 feet of home run, but you've got really 3,000 feet of number 12 inside that 1,000 feet of conduit, right? Because it's multiplied by 3. So you want to separate the conduit run from the wire run, right? Right, because the wire goes inside the conduit. Right? So the conduit is holding 3 number 12s.
Right. 3 of 2 different wires. 3 of the same wire connect to one and one thing.
Right, because remember when we do our home run, it's remember we got hot, cold, and neutral. Each one of those gets a wire connected to it. So we have 3 number 12 wires running through that one piece of conduit.
Just that one with the home.
Right, exactly. You see, visualize that, because that's really what it is. It's 3 wires that's running in that piece of conduit. So when we measured the home run as a entity, right, what we really meant is, if it's 100 feet, even 1,000 feet, whatever, as an entity, what we really meant was 100 feet of the conduit, but inside that conduit, right, is 3 times that 100 feet, because that's how we run home runs. It's 3 of them, or 4 of them, or whatever it tells us.
So however many triangles are on there.
Right. Right. Well, exactly. Yes. Okay. So now we're to the lighting plan, which I always do last, because really all we're doing is counting. We're looking at the lighting symbol. So make sure you are differentiating between what they call the light and this thing, right? That is just the zone, right? Because the lighting plan shows us all the lights and how they're controlled. So they're showing the electrician that certain lights are in zone 1, certain lights are in zone 2, you see? So when we want to cut on certain lights in the building, we can cut these on, those off. And so that's what all these symbols on the lighting plan telling the electrician. One thing is
Right.
identifying.
Mean what is labeled though.
Right. Right. So it's telling the electrician two things. Well, really, it's telling them three things in this one little section. It's telling them the name of the light, L500. We know it's an emergency light because it's got that little black dot. That's how they differentiate between the regular lights and the emergency lights. Emergency lights are the ones that stay on at night or in the event of something, they come on. So that's how they tell the electrician the difference between, because they have different lighting configuration, the batteries, something about the emergency lights are different. So they have to know that the difference between the emergency lights and the regular ones. So this is telling the type of light, and this is L500 EM. This is just L500. We've got all different ones. This is, I don't think that's a light. That's some kind of sensor. So yeah, we're going to look at the symbols list in our lighting plan to tell us what that is. Okay, that's some kind of directional sensor. But then again, it's all connected to zone 1. So this tell the electrician all of these lights, it looks like, in this little area are zone 1 lights connected to that 9 is actually a position probably in the lighting control panel. So just like the outlets, right? They all have the same number. Well, that's telling the electrician that these are all connected to the same lighting control. And we're going to call it number 9. Okay? Right now. Right. And see, now we have to do the wire runs for lighting. This is where it gets tricky, right? It's like, okay, how do I do that? So it's just like shotgun. So I would do like, I would, because they're all 9s, right? I would all connect, because they're all connected together. And I would go down here, and they're all connected together. And then I go over here, and then they're all connected. Okay? And at some point, they'll be connected to, this is where it takes your imagination on your wire runs, okay? And again, you're not trying to be exact. You're just trying to account for the lighting. You're trying to account for any wire that needs to be connected to these lights. These are all 13s, so these are all going to be connected together. Okay, all the 13s. And then look, the switch. Go ahead.
At this point too, when you're doing those counts, one of them in the row or the daisy chain has to go back to the next,
Right, yeah, right, exactly. It's got to go to wherever. And see, we haven't reviewed this in detail. Like, what is number 9? Well, it's probably one of the panels is probably a lighting control panel. You know, so just think everything is connected to power. It's just like, what is this telling the electrician? This little room right here is telling us a lot. These lights are called L8S, and this is an emergency light. They're connected to, their zone is Z20B. So what that Z20B is probably a position on a lighting control panel where they're all connected together. Right? At position 15. So all the 15s are connected together. And this is zone, you know, we got to read what all of this is. Okay, what Z20B, it's all in a schedule explaining everything that it is. So what is this? This is telling us what? These are the switches for this room. But, okay, as far as the conduit run, I mean, how do we do it? Well, probably like this and then that, okay? You see? I mean, how complicated could that be? From the switch to the light to the other light. And then, you know, my thing is, we got to know what all of these are. Probably some kind of, occupancy sensors kind of stuff. Or this is actually a light, Z17. Probably like a pendant light in between these two bar lights. Who knows? But that's the whole point.
So, and then it's the wire that has to, obviously, one of them that connects to the daisy chain, the conduit too, goes in one of those little sacks of the pin.
Right. So look right here, right? So here we are right here. So switch Z1, switch Z10, switch da da da. All this is the whatever 3 is. This is the switch bank they're showing us right here. So yeah, all of these are going to be daisy chained together, and at some point they're all going to be connected to Z1, Z17. We probably got more than one switch bank. But yeah, I mean, this is where the imagination sets in because
Right.
it's like, okay, first thing you're going to do really, just count all the different lights. That's the first thing. Count all the occupancy sensors. Figure out what this is. This is some kind of occupancy sensor. Okay, so count all that stuff. And then, yeah, use your imagination because you know that, again, it's telling the electrician all of these are connected together. And then I'm going to go to the panel because one of these is the lighting control panel. So that's power.
And
That's
I mean,
power.
do these things plan also? Does this sort of have a transformer and then
Here we go.
every
So this is existing. This is existing building, right? We did some demo. They got rid of those. So as far as your power, your single line diagram, the transformer, all of that is already existing.
okay?
Existing, da 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 da, meter
And
service. So what we
and
need,
you
go ahead.
run any the building, right?
No, no, because this is the extent of your single line diagram,
Right.
right?
It's already there.
Yep.
And,
This
okay.
symbol right there, that means that there is more that we don't see. That little S that says, well, all you need to look at is what I'm showing you here. Because this is, and that's telling us, oh, it's already existing from the landlord. What we're doing when we moved in, we demoed the existing panels that were there, and then we broke into, because this is the existing service coming in, we just disconnected here and reconnected ours to the meter, our PP1, and then our PP2 and PP3. Now,
Okay.
now, here's the tricky part, right? To go from how many linear feet of this do I need, right?
Mm-hmm.
How many linear feet of this do I need? How many linear feet of this kind? Well, then you have to go physically to the electrical, the power plant, and do the physical measurements, which when we saw the power plant, they're not, they're right there, right? The distance from, let me do a dimension tool. So remember, you're going to go across and down. So this is because the distance is so short, right? 5 feet between the panels in reality. So I would give it like, just add, I would give it like 15 or, something good. Just so I'm padded on my estimate. Because you gotta go up, across, and down, right? I'm just going across. So the full length from one panel to the other is less than 10 feet. In reality, right? Because this is supposed to be reality. That's why we scale them.
That road straight.
See, and then I would add like 6 feet for each time we got to go down or whatever. But, when it comes to those power feeders, we're talking what, maybe 15 feet each, 20. Even very generously, I give him 20 feet.
Very.
Yeah, right?
And for the new guy.
Yeah, right. Right, exactly. So, that's not difficult at all. All right,
Yeah, it's
so,
amazing that I just know on the plans that I've been seeing on my end have a lot of transformers, and it's really hard for me to understand how to get that part of it to connect to the building.
okay, so let me see if, let me,
But if you have classes, other classes
yeah, I
going,
do.
I would love to go
I want to
there.
see if, maybe this Dutch Brothers was from the ground up.
Oh yeah, my favorite.
Oh, it was. Okay. Yeah, it was from the ground up. So let's see. You said your favorite. Where is mine? Was this from the? It is from the ground up. Okay, let's see. Oh, that's right. I did the final cleaning estimate. I didn't do the electrical. So hold on. That's right. This is from the ground up. So let's go back. Come on. All right, here we go. Here we go. Perfect. All right, so here's the building, right?
Mhm.
There's the building. And then look, here's lighting because they got the big drive through and everything, right?
Mhm.
So let's see. Let's look at the schedule to see where the transformer is. Let's see. For utility transformer, location of utility, meter disconnect, let's see. Let's see, where does it say? Conduit, where do I see? Menu board. Okay, we'll find it. All right, so you say, well, let's just pretend let's probably, where is it? My goodness. Well, let's assume,
And you check that line right and the power plan.
no, I mean, the utility transformer would be outside, right? Utility transformer is the one that comes from the utility company that's out, usually like the green thing that's outside apartments or whatever. That green box.
Yeah.
Okay, we're just going to assume it's right here. Because we don't care where it is. Because we know that right here is the disconnect switch for the building. Okay? And this is the building itself. So if this is the transformer, you know that all of the power feeders are underground. So we would just do a measurement, scale this set, scale the site set, which is 1 over 32. So let's do that. 1 over 32 equals 1. We agree. So, again, remember, you're not trying to get exact. You're trying to give the electrician a good enough number to give a good allowance as to how much to charge. And we're always going to add more. So, even if this is the transformer and we know that that's the disconnect, well, we're going to say feeder. And we know it's PVC. So if this is the transformer, as you know, it's all going to be underground until it gets to the building disconnect. Now, that's all underground. But then what you're going to do, so from the transformer, right? It goes underground for sure. It's not going to pop up and then. So from the transformer, it goes down. It's all underground. Then when it comes to the building disconnect, it comes up, right? And so
Yeah.
what you can do is all of this is PVC, and then you can allow another 10, 15 feet for EMT or rigid steel because you know it's going to come up, right? And so when it comes up to the feeder, let's try to find the single line diagram now.
And then it should tell you in the or the sketch what type of conduit.
Oh, yeah, definitely. Hold on. It's going to tell us right here. Let's see. That's the lighting control. See, it's a little building, but see, and that's all the little kitchen equipment. And here we go. Okay, so switchboard. Look, so here we go. That right there, right? So that measurement we made would be two sets of four 350 and a 3-inch conduit. Okay.
And that would be steel.
Oh yeah. I mean, we already did it, right? We did it here. We already
Yeah.
scaled it, right? When we did it here, we scaled it.
Agreed.
So that's what. Oh, I didn't mark that sheet. Oh, Stacey, that's this. We already did that because it's coming
Right.
to the disconnect switch, right? This is the disconnect
Yeah.
switch, and so now we need
I
to
guess
do.
I'm just,
Go
you know,
ahead.
sometimes I'm gonna miss stuff on other pages, like, you know.
Yeah. Well, see now, if it's from the ground up, then yeah, you got to find the site plan because the site plan is going to show you. And don't use the civil set, right? The civil set has nothing to do, even though there's the electrical is shown on the civil set. The civil set has nothing to do with the specifics of electrical. So you're always going to look at the E plans. If it's from the ground up, just like this one, the Little Bitty Dutch Brothers, right? It's going to have a site plan. Now, because it's going to show us where the utility transformer is. We just don't have the time to go through it on this one. But
But
I
you're
said,
right.
imagine it's right there. Well, if it is right there, we've already done the measurement, which accounts for this right here. So that's 132 feet to the disconnect switch. Okay, and then you say what? So 132 feet times 4. Oh, times 8. 8, right? Because you
Okay,
have
two
two
sets.
sets. So don't forget that because you have two sets, meaning it was 132 feet. It's really 260 feet, right? Because you have two sets. Okay? So if I have two sets, that means I have times 8 instead of times 4. And remember, if it's underground, it's going to be PVC. So it's 3-inch PVC. And then it looks like it's still underground until it gets into the disconnect. I don't know. That may be just for a picture, because if this is underground, well, this is showing it's still going underground up into the disconnect from underground. I don't know. That may be right. That may not be right. Okay.
Okay.
So as far as additional conduit beyond PVC for this run is what I mean. And then this run, of course, is
Still,
showing. Go ahead.
and still PVC, yeah.
Yeah, right. This is PVC. All underground is PVC. All the way to the whatever bus duct or whatever they're going to use to connect that to this. And then here is telling you what it is. So now, yeah, you're going to go back to our power plan. And I think we did that distance, right? Oh no, that's a different plan. So we go back to the power plan to measure that physical distance. And then two sets of whatever this tells us. And then, you know, the power plan for all of these distances.
Mm.
Okay, so
Right.
single line the purpose of the single line is just to show you how the power comes into the building and how it is broken between the main distribution panel and all of the service panels, pretty much all of the panels that connect everything in the building that needs power. So yeah, this is just for an overview, but yeah, you got to go back to the power plan itself. Uh, got to go back to the power plan itself to find out where the panels are. This is not a nice plan. Where are they? Yeah, it's not. And here's all the rooftop. But where are the panels at? Oh my God, Dutch Brothers, you make good coffee, but not good plans.
Yeah. Yeah.
You would think there must be another sheet with it on it. Okay, yeah, there we go. See, they give you another sheet because they want to. Oh, that's good. They're going to show you how to run the network because this is all conduit for us, right?
Mm-hmm.
Camera,
The data.
right? All of that. So it's kind of good. It's nice. Network cabinet, da da da, mud rings, da da da, low voltage. Yeah,
And
yeah.
when you measurements, right, and you're putting them on something, you, and I've been told both ways, like, people
Uh huh.
add everything together. Like, if you're doing it pricing, you have to put that way, like, for your pricing, add all the measurements together, and the same, and then how that. but then other people say don't do it that way. Have it broken out by section or by page, like if you're doing a plan schedule or
Uh,
plan or
well,
sliding schedule.
yeah, well, you know what? It really depends. And let's go to the next part. Now that let's go to the estimate. Because this has been a winning combination for me and for my clients like forever. And so the way that we
Okay.
separate everything, once we've done all the measurements, right? So we know like that power, the MC cable, when we made all those measurements are the ones that are daisy chained. So we know how many
Mm-hmm.
linear feet of that for the lighting and for all of the signage and for the power. And this is for a city brew, uh, like a little Starbucksy kind of place. But this is what we do. So for number 10 wire, we give it all separate. So all the wire is separate. Number 8, number 10, based on all of the wire runs. And you see number 12, right? You see number 12 is
Yeah.
5,130. Well, why? Right? Because everything is pretty much always number 12, and you multiply by
Mm-hmm.
3. So that's why number 12s are always more. You have a number 12. So this is basically how we do it. The wire, we break it down based on the takeoff, right? Actual measurements. Conduit, based on the takeoff, the actual measurements.
Yeah.
And we try to break it down for, the data, phone, speaker, from the power, from the different sizes, da da da. And again, these are our home runs, 3/4 inch. And then all of the
Mm-hmm.
wiring devices.
Is that what with bolstering means? Does that mean your home run?
Now, when it comes to with pull string, the only thing that we do, and you see the cost, is that we
Yeah.
revise from day one as estimators that to incorporate the cost of the pull string, you double the cost of the conduit. So in this case, the conduit would be half of these prices, but because we do incorporate the cost of the pull string, we double the price of the conduit. Okay, so yes, that is conduit and pull string. So how we read this, and let's go over that quickly. So this is our Excel spreadsheet for the electrician. The quantity, right? How much we measured, and then the cost based on our, supplier, and then this gives us the total material cost. Now here's our labor base rate, standard base rate for an electrician, and then this is the man hour unit. Okay, now this is the number that I say based on industry standard, blah 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 blah. Well, the man hour unit is the amount of time that the construction industry says it takes for you to do anything in construction. And so
Mm-hmm.
to install one, because it's per unit, and a unit in this case is 1 linear foot, construction industry says it takes 0.011 of a man hour to install 1 linear foot of this type of NC cable. And so we know how many man hours to do the whole job. Okay, so that to
Mm-hmm.
me is the key of having a very tight estimate, a very competitive estimate, because a lot of people just, what do you base your time on? Experience? No, we recommend that you base it on industry standard. That way, you're very competitive, right?
Mm-hmm.
And that's what
Do
you want to
you
be.
does your program provide us information of the industry standards, or does that come with the
No, that
program?
comes with. Hold on one second, and that so we do things in a 3-step process. First step is the takeoff. The second step
Mm-hmm.
is getting and let me put this on the screen. This is what we use for our the industry standard stuff. So let me just put in switch. Okay, switches. Let's do electrical switch. Okay.
That's not price. It's just that. Oh, it does have price.
Yeah. Okay. So this is Craftsman Cost Book, which gives you the we put in a zip code, and here it has a Sacramento zip code. So this is basically telling us what the basic bare bones cost for each of these items is. But most importantly, what we use it for is for the man hour totals. The number after the at sign, that is the industry standard, and Craftsman Costco's been around forever. And so
Yeah.
they give you the industry standard on everything in construction, whether it's a switch, whether it's the conduit, whether it's a wire, and that's the number that we use in the Excel spreadsheet. The number here after the at sign basically says what portion of a man hour does it take to install one. So the unit is each. So for each switch, so it's saying here now, we're not talking about it says labor includes connecting wire to a switch and securing the switch in the box. Add the cost of the box and the cover plate. Okay, so this is just the switch itself and the time it takes to do just what that said. Okay, so if you're doing an actual switch, you're going to add this, you're going to add the box, and you're going to add the cover plate. The for in that case, it will give you all three. It'll give you the cost, it'll give you how long it takes. So those three things added up is what we call the assembly price for that switch.
Yeah.
The assembly is all those three things added together. Okay, so that's where we get that number from on the Excel spreadsheet. Okay, let's go back to the Excel spreadsheet. So that's where we get this number from. And then if you know how many, right, you're doing, and you know how long it takes to do one, then it's going to tell you how long it takes to do all of them. And so eventually you'll know how long it takes to do your entire job, because we do the same thing for all of the outlets, okay, all the wiring devices, whether it's J boxes, duplex outlets, and see how we broke it down. Some in this project it had 20 amp duplex outlets, it had 30. They had some above the counter. They had 40, 50. They had a duplex outlet in the show window. Duplex outlet connect only, right? Because the ones in the rooftop units are already provided. So the electrician usually just has to connect those. Okay, so
Did you go back up to the full string? Sorry, one second. So I'm trying to figure out, so data and speak. But then down on the you also have some that are labeled the wire and speaker.
So
what is
which
what full string?
this is okay, no. As far as the conduit with pull string, that
Yeah.
what that means is that's the cost. We include the cost of the conduit and the pull string. This is the time it takes to install the conduit only. Okay, so this is the cost of the conduit and the pull string. This labor is the cost to install conduit only. So by the time you add the cost to install the conduit and then the wire, then you've incorporated the cost of running the power wire. You see?
Yeah.
And then two, these are the costs to, just like we read before, to install the duplex outlet. So now you've installed the outlet, connected it to the wire that you've already installed. You see, and we work our way down. All of the wiring devices that we've added for everything. And then now we've got to the switch gear. Okay, so also, depending on the type of panel, right, it's going to take you a different amount of time. And really, the more positions on the panel, the longer it takes to install that panel. So we have the cost and the time it takes for the panel only. And see, we have zeros here for the panels and for the lighting, because we have a lump sum at the bottom to lump sum all the switch gear and the breakers, and then a lump sum for all the lighting and the lighting controls. But here we incorporate the labor only. You see, you see how that's different? So these numbers, right, where we get these numbers by counting from the panel schedule, right? We just went to the panel schedule and counted. And I thought that once I sent the panels to the supplier, right, that they would do all the counting. But my electricians say no, count it separately. They count it too because sometimes they're wrong. So I'm like, oh, okay. So you know, yeah. So we count that because yeah, for each of the breakers, there's an amount of time it takes to install each one into the panel. Okay, and then same thing with the lights, all the lighting, install only, right? And the site lights, you can see those are different. Give them 2.5 hours per light for the site lighting, and then just an hour. And then if it's track lighting, because it's measured by the linear foot, we price it by the linear foot as far as install. It's a different cost. And then all of the lighting controls, ceiling occupancy, wall occupancy switches. Give a generous amount of labor for that. It's probably more than is needed. And then last but not least, right? All of, like you said, the lift. And we just give them a general amount. If they need more than that, they'll adjust it, right? And then this had a drive through. So the loop, directional signage, menu board, speaker post, all of that is time it takes to install or to connect the power to. Because we already ran the wire, right? We already ran the conduit. So we give an additional time to actually install it, make sure it works, check it. That's what this stuff is. Mm-hmm. And then there was a walk-in, like the walk-in freezers or whatever. There's always additional, like, what is that, heat tape and all kind of crazy stuff they have to do when they install coolers and freezers and stuff. So I just gave them, and it's called an allowance. I'll give them allowance because I know they have to spend something on it, but I don't know the exact amount, right? So you give something as opposed to nothing, and let the electrician adjust if it is appropriate. But always account for it. Yeah, right, right. And then here at the bottom, you see where we got the lump sum for the switch gear and for the lights. And the lights always make it crazy. I mean, lighting is just crazy. See, and then I leave it zero for the overhead and the profit and the tax and whatever. But then here at the very bottom, I always give the relevant links, right? So they can have an idea, like, just from, now this one, that's right. This one that I didn't give us the wire configuration for the power, for any of these. And so I was like, okay, I don't know what size wire you need, but I'm just going to give you the lengths of everything. So that's what that's what I tell my electrician, tell the GC, here are the links for these, totals from the site plan. Right. And basically it said like based on design or something. I guess it was a design build that they hadn't figured out what it needed to be. But me as an estimator, I'm not an electrician, right? It's not my job to try to figure out your wire configuration, right? Because you want me to do it, something probably set on fire. So I can give you the links, as a good estimator should. But then, I told him if you know what your configurations are, just give it back, and then I can update the estimate. You see?
Question: what they would be? I don't know with your spreadsheet the profit and overhead.
Uh huh.
Do you do the 1.2%, like 3%, or
It really depends on, you know, there should be, there is a way to determine your actual overhead, right? Overhead's based on a lot of different things, but most people do 10 and 10 or 10 and 15 and what I recommend is, now it really depends on the kind of company that this company is. If it is like a huge company, which sounds like your company is, where you have a lot of employees and their trucks and there's fringe benefits and vacations and workers comp and stuff like that, usually they will have a higher margin of overhead, of course, right? Because you have all of that fringe benefits, all of the workers' comp. So that overhead is usually 20%, 25%, something crazy. And then the profit may be a little lower. I mean, it really depends. But what most of my clients are like mom and pops, right, that do their own work. And what I recommend is, do a reasonable base rate because you're making all the money, right? It's not like you're paying a, a crew. You're taking home that money. So give yourself a decent hourly rate and maybe 10 or 15% combined or 20% combined overhead and profit because you do want to be competitive. So it really depends on the business structure how you do that. I mean, most with
Right.
a lot of
We
overhead.
usually do
Hmm.
about 40, and then I go in and or excuse me, we usually do the over and it's on the 40%,
Yeah,
and
because you
then
do.
yeah, and then we do our over for the profit. We don't market. I go in and do that individually.
Yeah, yeah, right. Because you want to make something, right? You can't when you have a big firm with a lot of overhead. I mean, that's pretty much eats up your profit, right? So it really depends.
So that's what
And
you
what
would
kind?
just put 4%.
Again, if you guys are using 40% overhead, what are you using for as far as the hourly rate? Are you using a base rate of for
Oh, we
your?
do the $30 an hour.
Okay, yeah, yeah, yeah. Well, then that's right then because your hourly rate's not very high. You go with the
Yeah.
base rate. So yeah, your overhead, and then I would do a profit of like 15% if you guys are going with $30 an hour for the base rate.
Okay.
Yeah,
And then
because
you're
you're not.
going to
Some
divide it.
people do like, oh, I want a $95 hourly rate. I'm like, okay, well, then you're not charging
Oh,
any overhead or profit then because you incorporated it in your hourly rate. You know, and you guys are doing just the opposite. You're giving a very low, which it should be, base rate. So yeah, you can charge a higher overhead, which it is because you do have overhead. But then you can give I would play with it to see if you lose, why? And maybe it was the overhead was, I mean, the profit was a little higher than it should be. I mean, if you're doing a 30 for the man hours, I would be in 40 for that. Yeah, I would be doing at least. I started at like 10%, try to work my way up to 15 to see how 10 did.
okay.
And just
Cool.
like you said, you guys play with it. Because yeah,
Yeah.
you want to make your
And on
money.
your, does it change all of the numbers or just the size total?
Say it again.
On some, like when you change like the overhead and the profit percentages, it changes everything within each,
Oh
or
no,
does it just do it?
no. I mean, it just changed the bottom line. Like in our case with this one right here, the
Yeah.
78 894 is set. See, you see our overhead and profit is zero and zero. So, that's that's the last thing you put in, right? Is your overhead and profit
Yeah.
because this is supposed to be your actual cost, right? Seventy
Yeah.
eight, 894, 91. That's supposed to be out of pocket. And I really don't add very much markup on the material. So you could even add a markup on the material. I mean, if you did it, you could do it within the Excel spreadsheet actually. To mark up the material, we can make, because this is an equation, we can make it. Oh, they did. Okay, no. See, we could say that times 1.1, right? If you do it times 1.1, you've added 10% to your material cost, right?
Right.
One, you're multiplying it by itself, and then you want to add 10% more, so it's 1.1. That could be an equation, and I'll give you a copy of this one fresh, so you can go in and play
Okay.
with it and use it if you want to use this one on your own.
Awesome. That'd
Yep.
be amazing. Thank you.
Yep, and it'll save you time. But the thing about it, your supplier now, you're going to go and do what your cost is, you know?
Right.
But the man hour totals, if you need assistance with that, just let me know because I can give you access to this uh, craftsman so you can play with it for a little while. And it too, if
Yeah.
you
That'll.
take the class, I will definitely give you access to it for the remainder of the year. So,
Okay. Cool.
yep. All right. So, Any questions?
Um, I yes. For when you are doing it, I rented to just recently. I just did probably three subjects last myself, and with the general
You
and
cut out.
listened to.
You cutting
Oh,
out.
sorry. Um, and I just noticed when I'm submitting my estimates to GCs or whomever, the inflation and the lead time and waiting right now is so crazy that
Uh-huh.
they're not getting back to me within 2 weeks, right?
Uh-huh.
I do my standard like follow up after the 14th day, just send them a little email, hey,
Uh-huh.
just following up, yada yada. And they're like, oh, we're still just waiting to hear back. And then finally they just say, oh, you got the job. Um, we're expected to start next week. And I always try to put a big fidelity date on my estimate. Um, but I just don't know what you maybe think is appropriate, or do you ever have a bid fidelity?
You know,
Uh,
you guarantee, like at the bottom of all of our estimates, it says, it's based on plans and specifications and good for 30 days. So at the
okay,
end of 30
30 days.
days, you have to reevaluate because, like you said, with the inflation and with the price of copper and everything, you have to
Right.
reevaluate your wire costs almost on a weekly basis.
Literally, like for right now, our transformers, like
Uh
to
huh.
get any transformers or pads in, is a 3 year wait time.
Oh, see that? I mean, how is that's not even sustainable. I mean,
Right? It's not even
it's
possible.
not even
Like with one of our
possible.
people who's get them from, they're not even taking new quotes. And so, he's like, you can give them a bid, but you got to let them know that it's definitely going to change by the
Yeah,
time he approves it or wants to
right.
go through with it.
And see now with the way
So,
things are now, you might have to like systematically come up with a new protocol on how to do this because of that. You know what I mean?
right.
It's
I
like,
just didn't know if you'd experienced that as
yeah,
well.
with everything, especially with with one of my drywall people, they were saying that mud went from $19 a bucket to like $89 a bucket
Oh
overnight
my
for
God.
the drywall. I'm
Yeah,
like,
but
yeah. I mean, that's scammy and bad all at the same time.
that is
That's
terrible. Well,
terrible.
milk right now, just a damn bottle of milk here in my town is like $8
Oh
in
man.
Utah.
Oh man. Yeah, I mean, it's like I don't know, and it appears that people are still building stuff. I mean, I'm still getting
Yeah.
requests for big estimates. I'm like, okay.
Yeah. I mean, me too. I get more than I can handle every day. I wondered if there was a better way of writing. Maybe, like, I noticed that experiencing, like, instead of bid fatality, like, should I put due to inflation and um, lead times? Like,
Right. I mean, you have to
I,
give them as much information. You give them the same information as you're getting. Let them know the
right,
lead times and yeah, each estimate is only good if you can. I mean, we've not ever gone more than 30 days when it wasn't bad. So
okay, cool.
yeah, I wouldn't guarantee any estimate more than 30 days. And yeah, you just have to keep them on a continuous loop on following up because that's just the way it is,
Right.
you know?
Look,
So,
my boss, before I started working for him, he would never put a damn go-to date. And so he was getting screwed on some of these things right when this whole material
mm-hmm.
inflation. I was like, Harry, you
Yeah,
got to put this on good for a couple days.
yeah,
And then
right,
he's like,
right.
he's an old guy.
Yeah, right. And he's probably not used to this craziness, but even that being said, I would put each estimate out with a 2 week date. These prices are guaranteed for two weeks, and at the end of 1 week, I would just be checking on your supplier because you may have to change it. Nobody's trying to work
Right,
for free. Nobody's trying to work for free. So it's just gonna take you following up because I was one of my clients. I do get a update on the wire prices every 30 days from him.
oh,
So
nice, nice.
yeah, so at least every 30 days they should expect some kind of change if they haven't gotten back with you. And
Now,
definitely,
We're going to.
definitely on every estimate, let them know what all of the lead times are because at least that way they can't tell you they don't know or you know.
Yeah, you didn't tell me. I'm pulling out. Yeah,
Yeah,
bullshit.
yeah, right. Yeah, let them know on every estimate. And you know what? Right now, you're just gonna have to just triple follow up on them as you know. And doing these estimates take time. You know, so yeah, I'm gonna follow up until you tell me I got it or I didn't. And another
Yeah,
thing I recommend is if you
Robert over there.
say it again.
I said, yeah, throw off or tell me who got it.
Right, exactly. And if in the event that you don't win, you know, you don't have to ask them, you know, who won or whatever, because they won't tell you. But just ask them to give you what the winning number was so you can compare it to yours. That's all.
Absolutely.
If you
Let me
can
know
do
so
that. Yep.
he knows.
And that'll help you a lot. You can go back and review and see where you have could have made it a little more tighter or not at all. Because some people just lowball it and there's nothing you can do. But at least you know, at least you can feel comfortable that, oh, okay, I only lost by so much. And, you know, if somebody's doing it way cheaper, there's something wrong with it. Because you guys are professionals. You've been doing it forever. So,
They do their due diligence, look for shit, and they're going to get
right.
both upside down.
Like one of my clients says, yeah, Chuck in a truck, right? Somebody that just show up and lowball it and win and can't complete it, though, you know?
Right.
All right. Anything else?
Um, no, man. I this made me think. Uh, if we could, I know we've been kind of talking this email, but my boss Terry is gonna be really happy with this. He'd probably want me to sign up on something with you quite regularly. So,
I can help
if
you,
you just
yeah.
had any,
Definitely. I love. I mean,
yeah, if we
electrical
could
is my forte.
hang out in any chance, that'd be awesome.
Yes, definitely. And two, if you can, when we get off the call, please let me know what you thought about the class. I don't have a form or anything. I just, if you could just
Oh,
email me and tell me what you thought, and you know.
yes, yeah, you're literally this that I've been to. I did a couple of they were construction manager, project manager courses at the U of U here in Utah,
Uh huh.
and man, you just out of the water in terms of
Oh,
bullshit.
oh,
So
that is so cool.
you're
Make
awesome.
sure you yeah, tell me that in an email. That's awesome.
Yes, ma'am.
Thank
So
you so
send me
much.
over, yeah, send me over that spreadsheet and
Yes.
some of those man hours, and then totally we'll coordinate on some more classes and
Yeah,
set up.
definitely. You just let me know, and I will. As soon as this tells me it's finished, right? I'm gonna send you because I have it on OSB, so it's still recording. So we can have
Perfect.
this. It'll stay forever. So that's good. I'll make it
Awesome.
private. That way nobody can see it but you. And it'll be on my YouTube page, but it'll be private. That way nobody can
Oh,
log
that's
on
fine.
except for you.
Make it whatever. That's
So whatever. Okay. Well,
good. All
I'm
right.
gonna end the class
Well,
now,
yeah,
and I'm gonna be waiting for your email. And just let me know what other class you'd like to take. Thank you so much.
take it too.
All
Bye.
righty. Bye bye.